Today, I want to tell you a tale of two cities. They exist in the same climate, they receive the same amount of sunlight, and they are built with the same budget. Yet, on a hot summer day, one of them can be 10 to 15 degrees cooler than the other. The difference isn't magic, it's engineering. This city is experiencing what's called the heat island effect. This is a phenomenon in which urban areas become warmer than their rural surroundings due to factors such as loss of vegetation, changes in ground cover, and intrinsic properties of urban materials such as solar reflectance, thermal emissivity, and heat capacity. The question is, how do we combat this? Surely, everyone has heard of green cities. We've all seen the futuristic, AI-generated pictures of green cities with abstract-looking buildings and plants covering nearly every surface. Green cities in real life, though, look slightly different. They rely on practical, research-backed design choices, and I'm going to tell you about 3 of the most effective ones. Trees provide shade, obviously. They reduce the amount of solar radiation that reaches the area below the canopy. Usually only 10 to 30% of light gets through the branches of the tree, with the rest being absorbed by leaves for photosynthesis or reflected back into the atmosphere. Researchers have found that placing trees strategically around buildings, parking lots, and other open spaces can significantly cool ground temperatures. Certain plants, along with specially engineered soil, can prevent sunlight from reaching underlying roof membranes. The cooler surfaces below the plants can not only reduce the amount of heat transmitted into buildings, but also the amount of heat re-emitted into the atmosphere. A multi-month study conducted in 1997 measured maximum surface temperature reduction due to shade trees ranging from 20 to 45 degrees for walls and roofs at 2 buildings. The shading provided by these plants works together with a process called evapotranspiration, which is the process by which plants evaporate and transpire water. While plant shade reduces the amount of sunlight that reaches the roof, evapotranspiration further cools a green roof by using heat to evaporate water from the growing medium on plant surfaces. Understanding green roofs requires an understanding of how properties of roofing materials can contribute to warming. Solar energy, or albedo, is the percentage of solar energy that is reflected by a surface. Traditional roofing materials have a low albedo, which means that they absorb 85 to 95% of the sunlight that reaches them. Thermal emittance is another important property of roofing materials. The thermal emittance of a material tells you how much heat it will radiate per unit area at a given temperature. In other words, it's how easily it gives up heat. High emittance materials give up heat more readily, while low emittance materials hold on to heat longer. Engineers have found that using the properties of solar reflectance and heat emittance to their advantage has significant effects on surface temperatures. Research shows that roofs with high solar reflectance and high heat emittance tend to stay within 10 to 20 degrees Fahrenheit of background temperatures, compared to conventional roofs, which can be between 55 and 85 degrees hotter than the air surrounding them. When we return to our tale of two cities, the difference becomes clear. One traps heat with dark surfaces and minimal vegetation, while the other works with the environment set up against it. The smarter design leads to cooler cities and more livable spaces. This is how engineering, rather than magic, can change the end of the story.